Hey, good afternoon, Bridge. How are you doing? Hopefully well. Today is going to be our first day of notes. We're still having some fun activities, but I think getting some notes on some expressions is going to be very helpful for the next few things. And it's also going to jumpstart us into our first unit as well, which is expressions. So be ready to take some notes, get your notebook out. Some of this will be review, some of it will be pretty simple. Some things are just good to get down, okay? So first off, we're talking about expressions. You may not think about them because we use them so often, but anything that contains numbers, variables, or math operations is considered an expression. So for example, 4. Whoa, it's an expression. It contains a number. What about x minus 2? Hey, check it out, another expression. I've got a variable, I've got a number, and I have a math operation, all right? So that's like add, subtract, multiply, divide, anything else that you could think of. Parentheses, exponents, right? What about square root of x plus a minus 14? That's an expression, okay? The difference between expressions and equations are that equations are actually setting an expression equal to something, say 3, and then you would have to be, you'd have to try and solve for that. So the difference between expression and equation is in expressions, nothing is set equal. We're just looking at this and seeing what we can do with it, okay? Again, they're not going to be this complicated, but that's an example of an expression. Anything that has numbers, variables, or math operations. You can evaluate if you just have numbers in your expression. We should be familiar with order of operations. So what if I had 6 times 3 plus 2, right? Parentheses, again, this is something you should know. PEMDAS, parentheses do what's inside first. So inside I have addition, so I'm going to take care of that first. And then you can multiply, all right? So again, this should be pretty much review, but in case you need your order of operations, get these down. I have multiplication and division and addition and subtraction in one whole step because we take whatever comes first going left to right as we read, all right? So going from left to right, do whatever operation you see first, okay? We're going through these, you're doing good. Again, you can combine like terms to simplify expressions. You've been doing this for ages, so examples of like terms that you can combine, 4 and 5. You can combine those and you'll get 9, right? Simplify that thing down, you'll get 9. These are just numerical like terms. What if I said x minus 3x? You can combine those, they're like terms because they have the same thing dealing with them, right? I mean, we got x's here, we have the same variable. I can combine those and say, all right, those together is just gonna give me negative 2x, all right? A plus 3a, okay, you get the idea. Examples of not like terms, things that you can't just throw together, anything that has different variables. So like a plus c. They're not like terms. They're variables, but they're not the same variable. So you can't combine these, all right? So often I'll see something like 4b plus 2ab, and some people will try and combine them and say 6ab. No, again, here we've got just a b. Here we have a and b being multiplied together. They're not the same thing. So this is as simple as you can make it. And then this here, again, as simple as you can make it. No like terms to combine there. Okay, we're rocking and rolling. Again, anytime if you need a pause or rewind, please do that and get down some examples or notes. Expressions can represent real life. We're going to use these later, not so much in the next day or two, but I do want you to know some of these key words, all right? So you don't have to write down this, but I would make yourself a little like graph or make a little think bubble, whatever you want to do. make sure you can write down some examples of addition, some examples of subtraction. Maybe you go through this list and you write down the ones that you don't know, okay? So when I'm thinking addition, sum, I know that one, I don't want to write that one down, okay? When you find the sum of two numbers, you're adding them together, obviously. Increased by, that one just kind of makes sense. Add, plus, I mean these ones, right? Write them down if you need. What about perimeter? Perimeter, if you think about it, maybe you want to find the perimeter of your garden, all right? The perimeter is the distance around an object. So there you would be adding all of these lengths, all right? So that one you may want to write down to remember, okay, when I'm talking about perimeter, I am adding a whole bunch of stuff. Let's see, total, okay, subtraction. Again, these ones should be common knowledge. Take a second, pause, write down some ones that you think you may want to remember, some key words. Moving on, I also have multiplication and division, all right? Again, go through these, make sure they make sense, because again, I'm going to give you a sentence later on. I'm going to give you a sentence and I'm going to ask you to translate it into a mathematical expression. So if you see double, okay, thinking about multiplying by 2, be careful here. Oops. Double means, so if I wanted to double x, I would say 2 times x, all right? I would not say x squared, all right? That's a different thing. This is multiplying x by itself twice. This is just taking x and like adding it twice. It's like repeated addition, okay? Or if I said triple, you would be multiplying by 3. So if I said, you know, triple 5, you would say 3 times 5, and you would say, okay, 15, all right? Division, again, quotient, that kind of fancy word that we learned in elementary school. 3 out of 5 would be a fraction. 3 out of 5, again, fractions are really like just division. So you do 3 divided by 5, you will get a decimal. Again, take a second. Here's your next one. Parentheses and exponents. Parentheses are kind of an interesting one because they combine a whole bunch of different operations. So you have to read a sentence very carefully with these. So again, in parentheses, these are examples. They're not exactly keywords, but if you see something that says 5 times the difference of blah, 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 you know that you have 5 times the entire difference. So maybe it was x minus 3, all right? The difference of x minus 3, 5 times that entire thing. That keys you into saying, okay, now I need to use parentheses. Or 4 plus the difference of. Or how about twice the sum of x and 3, okay? 2 times the entire sum. Make sure that entire sum goes in parentheses before you multiply by 2. For exponents, we'll also run into some of these as well. So make sure you know when I say x squared, okay, raising it to the power of 2. So x squared, 4 squared. If I said b cubed, that would be raising to the power of 3, right? Or if I said 9 cubed, or if there's anything above an exponent of 2 or 3, I would just say to the power of 5. So x to the power of 5. All right. Again, we'll get into what all of these mean exactly, but I just want you to know these keywords and have them written down somewhere. And then the last one is equals. Again, if you're reading a sentence, any of these may indicate that you are setting something equal to something. All right. Okay, so hopefully you were able to pause and get some of those notes down. Let's talk about some patterns, because we were using pattern day last Monday. So we're going to be able to write expressions for patterns. Now being able to take it to another step. So I want you to take a look at this pattern. And I'm asking you how many stars are in the 6th iteration of this pattern. So you could draw these all out, but there's got to be an easier way, because what if I ask you for the 106th pattern? I'm sure you probably don't want to draw out a ton of stars, right? You want to find an easier way to do this. So let's take a look. I like to just kind of have this example here, and I really like making a table of values so that I can start seeing patterns within the numbers. So that's what I'm going to do. And maybe this is how you want to do it as well. I'm going to say the pattern number, or I'll just say, the pattern, we know what we're talking about, and how many stars are in the pattern. So in the first pattern, check it out, there's the first pattern, you've got 3 stars. And the second pattern, okay, you can count them up, now we have 5. What is the difference between the first and the second? Okay, here I had this kind of corner star. Again, we're looking for patterns, so maybe we want to just look at it visually. We have this corner star, and then I have 2 on the outside. I have this corner star, now I have 2 on the top, 2 on the bottom. Notice how we're in the second pattern, and I have 2 here, 2 here, all right? What about on this one here? The third pattern, that corner star has still kind of stayed there, right? So that looks like a consistent thing throughout all of these patterns. So I have this corner star, and then I have 3 and 3. Again, notice how I'm in the third pattern, and I've got 3. You could think of this as like an arm and a leg, or a base and a height, right? So there's kind of some things that I'm noticing here. 3, what do I got? I got 7 stars. And we can continue this pattern without having to draw this all out. So on the fourth pattern, I'm gonna have 9, because I kind of know that I'm gonna be adding another star on the end here, on both of those ends. So I'll just finish this off. So 5, we'll have 11, 6, we're gonna have 13. But what if I asked you for the 500th pattern? What if I asked you for the 602nd pattern, right? I want to be able to do this for any number. I'm going to say any number n. I'm just going to pick a variable. When we're doing counting things like this, like I'm counting the number of patterns, we usually like to use variables n. X is usually saved for when we are solving for something. So I'm going to say, well, what about the nth pattern? Is there going to be an expression that I could write? So whatever number that you give me, I could just plug it into the expression and I'll tell you how many stars it would have. So let's think about this a little bit. What is changing and what is staying the same? It's kind of how I like to visualize this. The corner star is always staying the same, right? So that's one that's always going to be there in the corner. And then here, like we pointed out, whatever pattern you're in, you have 1 on the outside, 1 on the outside. In the second pattern, 2 on the outside, 2 on the outside. In the third pattern, 3 on the outside, 3 on the outside. So I'm taking whatever this pattern number is, and I'm kind of doubling it, because I have one of these bases, one of these heights, with the same pattern number that I'm in. Are you seeing that okay? So if I was in pattern 6, I would have 1 corner star, and I would have 6 up this way and 6 that way, all right? If I was in the nth pattern, I would have 1 star, and I would have n amount of stars and n amount of stars. So together, that would give me 1 star plus n stars plus n stars. We seeing that okay? We'll get some more practice with that, don't worry, all right? So I would have 1 plus 2n. Again, that 1 is accounting for my corner star, and the 2n is accounting for this kind of like base and height, which should have n stars in the nth pattern and n stars in the nth pattern, all right? So we were able to answer the question, and we were also able to provide a mathematical expression for any number. So if I said I wanted to know the 100th pattern, you could say, okay, I'm going to plug n equals 100 into my expression and say, all right, 1 plus 2 times 100, so 1 plus 200, 201 stars would be in the 100th pattern. Let's do another example. All right. So here we go. It says how many stars, how many blocks are in the 6th pattern, or the 100th pattern, or the 10 millionth pattern. Let's see if we can start to build somewhere where we can have an expression for this pattern, all right? Again, we're starting off basic with just these pictures, but eventually we're going to be moving on to writing expressions for real life situations. So let's say a pattern number and how many squares that we have in the pattern. Here I'm going to start off with 1. We've got 3 squares. All right. I'll move this over so it's not part of the picture. In the 2nd pattern, what changed? I've got those original 3 squares, and I can kind of see them right here. But I also added another 3 squares. So in the 2nd pattern, I've got 6. In the 3rd, all right, there's those original 3 squares. There's the 3 squares from the 2nd pattern. Here is another 3 squares. So in my 3rd pattern, I've got 9. You seeing where we're going with this? In the 4th pattern, I have 1, 2, 3, 4 groups of 3. So I've got 12, all right? Without even having to do this, how many are going to be in the 5th pattern? Or, without having to draw all this, I can just, think the 5th pattern, I'm going to have another 3 added on to the end of here. So just add another 3. That's going to give me 15. Again, are you noticing any pattern here? Are you noticing maybe an expression that we could write? I'm seeing that I'm adding 3 every time, or I'm taking my pattern number. That's how many groups of 3 that I have. So if I'm in the nth pattern, I could just take n, multiply it by 3, because I can imagine in the nth pattern there would be n little groups of 3, and I can keep going however big n is. So I would have 3 times n. So again, if I wanted let's make it easy. If I wanted the 100th pattern, how many squares would be in the 100th pattern? Okay, well, let's just say that in this case, n would equal 100. If I plug 100 into this expression, I would just be taking 3, multiplying it by 100, and I would get 300 blocks. Okay, I think you're getting the hang of this, hopefully. Let's do one more together. All right. So take a look at this. We're asking how many blocks. Again, we could ask in the 6th pattern, in the 7th pattern, in the 100th pattern. I'm really looking for an expression for any number that I'm just going to call n, right? So in the 1st pattern, I got 5. In the 2nd pattern, what do we got? 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. In the 3rd pattern, you can count them up. You've got 13. So again, what's changing? What's staying the same? I'm definitely noticing here, you could figure out a way to describe this pattern. I've got, how many times can I say pattern today? Seriously. I've got this one that's in the middle, right? And everything is kind of branching out from that. So I've got one in the middle. Here's my 1st pattern. One in the middle, and then I have these kind of like spirals on the outside, or these arms, however you want to describe this. In my 2nd pattern, I still have that one in the middle, but I have 2 reaching out on either corner, okay? Here I only had 1, because it was in the 1st pattern. Now I'm in the 2nd pattern, now I have 2 on each corner. So in the 3rd one, I should still have that middle square here, but now I have 3 blocks on each corner, all right? Again, now we're thinking about how can I relate this picture with the pattern number that I'm in. So what's staying the same? Again, I have that 1. So no matter what pattern I'm in, if I'm in the nth pattern, there should always be that one middle one that's staying the same. So I'm going to draw, where am I going to draw this? I'm going to draw the n one down here, right? So for pattern n, I have that middle block that's staying the same. And if I continue with this pattern, there should be, 4 blocks, 5 blocks, 6 blocks, however many number we're in. So in the nth pattern, there should be n blocks going this way, n blocks going this way, there's n blocks going that way, and n blocks going that way, right? So if we had to add this all up, in the nth pattern, there should be 1 plus n plus n plus n plus n. And again, n, those are all like terms. Could I just say 1 plus 4n? Hey, and there's our expression. Can we make sure then check to see if that works? So if I was in the fourth pattern, I could think about it as adding 4 more from here. So that should give me 17. Or if I used the expression, let's plug n equals 4 into my expression here. Okay, that would be 4 times 4, which would be 16, plus 1, which would give me 17. That checks out, that looks good. In the fifth pattern, again, I know it should be an extra 4 from the last one. So here I should have 21 blocks. If I check it with my expression, if I plug 5 into this expression, I would have 4 times 5, which would give me 20. And then 20 plus 1 gives me 21. So we're good. We've got the right expression here. So again, if I asked for the 100th pattern, you'd be able to plug in n equals 100 into here and say, okay, 4 times 100 is 400, plus 1, 401. Pause if you need to. All right. So this was a very good introduction to get us going with recognizing these patterns that we've been talking about and starting to connect them with a mathematical description. All right. So we are going to be talking more about this tomorrow, but for the rest of class, please do make sure to come back to the meet and show me that you had some notes today. Maybe you wrote down some examples, you wrote down some of those key words, you were able to follow me with some of those patterns that we just talked about. For the rest of class, I want you to think about this. There's no place to turn it in, but we're going to talk a lot about this specific problem on Thursday when I see you, all right? So show me your notes, come back to the meet, show me your notes, and then I want you to start working on this. Get some ideas down, all right? Pause if you need to, and I will see you soon so you can check off your notebook. Thank you, Bridge. You did great today.